This is Unit 15, Net Ionic Reactions, Part 1 Notes. By the end of this unit, you should be able to predict the formation of a precipitate in a double replacement reaction, also known as precipitation reactions. You should also be able to describe the information found in a net ionic equation. Precipitation reactions are a type of a double replacement reaction in which the reactants are reacting in an aqueous state of matter, that means they are dissolved in water, to produce an insoluble product in a solid form. So if you look to the right, we have a picture of let me change the color, tube number 1 and tube number 2. The first tube is going to contain silver nitrate. Using the solubility rules, this compound is soluble in water, so it looks transparent. Sodium chloride is also an aqueous state of matter because it can also dissolve in water, hence the AQ. So when we have two of these solutions being poured together, we see the solid precipitating out of the solution. That's because through the double replacement reaction, the Ag and the Na switch places. So the silver bonds with the chloride to make silver chloride, the sodium bonds with the nitrate to make sodium nitrate. Any nitrates are soluble, so that compound will still be dissolved in water. This silver nitrate, using our solubility rules, is insoluble in water, so there it will precipitate or come out of the solution to form that solid. So then your ionic equations are just going to show the substances in a double replacement reaction as they behave in solution. So if you have an aqueous state of matter, they're soluble. Solids, or the solid state of matter, is insoluble in water. So anytime you have an AQ, you need to separate those ions and keep in track of the mass and charges. We have to make sure it's balanced. Everything is a 1:1:1 ratio, so we don't have to worry about coefficients here. So AgNO3, whenever we break it up into ions, we have Ag plus 1 with the aqueous, and a nitrate, NO3, -1 charge, in aqueous. NaCl is also soluble, so it's going to split apart in water to form the Na plus and Cl minus ion. Anything that is solid, you keep together. It does not separate because it's insoluble. It will not break apart. Sodium nitrate is soluble in water, so then we split it up into Na plus and NO3 minus. And that shows you the overall ions reacting in solution. A net ionic equation is an equation for a reaction in solution that shows only the particles that are directly involved in the chemical change. Remember, dissolving is a physical process, so we need to eliminate any physical aspect occurring here. The only thing that we are worried about is forming the complete net ionic equation to show the chemical reaction that is occurring within the water. So we had our original equation, silver nitrate plus sodium chloride yields silver chloride and sodium nitrate. Again, double replacement, so the Ag and the Na switch places, and then they form two new products. We determined that silver chloride is insoluble in water, so it does not break apart. Everything else does. So silver nitrate separates into the silver ion, nitrate ion, sodium chloride separates into the Na plus and the Cl minus ion, and then your sodium nitrate is soluble, so it's going to break up into the Na plus and the NO3 minus ion. Again, we need to keep track of the states of matter and all the charges, so you have to carry down everything. This is going to be your complete ionic equation because it's going to show you completely every single ion that is within this water. The spectator ions are ions that appear on both sides of an equation, but they are not directly involved in the reaction. So what we have to do is we have to be able to locate which ions are on both the left and the right with the same amount and the same charge. So I look through this and I see that I have a nitrate ion on the left and a nitrate ion on the right. I also have sodium on the left and sodium on the right. So those are going to be your spectator ions because they are not involved in that chemical change. So what we do is we cross out any spectator ion. That is why the NO3 and the NAs are all going to be crossed out. The only thing that we're left with is going to be our silver plus the chloride ion is going to yield silver chloride. And this we just carry down, and that's going to form our our net ionic equation. So the overall net ionic equation is only going to show the species that are involved in that reaction. The complete ionic equation just separates out every single ion that is soluble in water, keeping together the insoluble compound. So a type of problem you would encounter would be to form the net ionic equation for the reaction. So if we combine aqueous potassium carbonate and aqueous strontium nitrate, we need to be able to identify the precipitate formed, that's going to be our solid at the very end, and write the net ionic equation for the reaction. Potassium is the element K with a +1 charge. Carbonate is a CO3 with a -2 charge. Aqueous strontium nitrate, strontium is 2+, and nitrate's an NO3 -1. So whenever we cross and drop our charges, we should end up with K2CO3 plus SrNO3 2. And we need to include the state of matter, and it says both of them are aqueous. That means they are soluble in water. That's going to be AQ for both of them. Okay, and they're going to react to form two new compounds. It's a double replacement, so we need to swap out the strontium and potassium. So we're going to form strontium carbonate. 2+ and 2- are going to cancel out, and then we have KNO3. Using our solubility rules, the nitrates are normally going to be soluble. If it's with an alkali metal, there are no exceptions to that. Carbonates are usually insoluble unless they're forming a bond with the alkali metal. Strontium's an alkaline earth, so it's going to stay insoluble and form a solid. So this is our complete reaction. We need to go back and make sure we are balanced. And by adding a coefficient of 2 in front of the KNO3, we end up having 2 potassiums and 2 nitrates on both sides. So our coefficients are a 1, 1, 1, 2 ratio. So for every ion, or for every compound that's soluble in water, we need to separate it out. We also need to keep track of how many there are. So looking at my potassium in the first problem, change color, we have 2 of them. So we have to make sure we put 2 potassiums with a +1 charge in aqueous form, plus we have 1 carbonate ion with a -2 charge in aqueous form. It's going to combine with strontium. Strontium is Sr, 2+ charge. It's an aqueous form. And then we have 2 nitrates, 2 NO3s, -1 charge, in aqueous form. And they are going to produce, our strontium carbonate is a solid, or it's insoluble in water, so we can't separate it out. We have to keep it there. So I'm going to write my products right below it. So SrCO3, solid form, we keep together, and then we have to separate out the other compound, product. So we have 2 K + 1 in aqueous form plus 1 nitrate, still in aqueous form with a -1 charge. So now we have to go back and then identify our spectator ions. So looking at our complete ionic equation that we just wrote out, I need to figure out what ions are on both the left and the right. I have 2 potassiums on the left, I have 2 potassium ions on the right. I also have 2 nitrates on the left. Oh, I forgot to add my 2. We actually have 2 nitrates because of the 2 in front of the K and the nitrate here. So we have 2 nitrates on the right. That means we are going to cancel out all spectator ions. So the Ks and the NO3s will be canceled out because they are not involved in that reaction, and everything left, that is going to be considered our net ionic equation. So our net ionic equation for this aqueous reaction is CO3 -2 in aqueous form, combining with strontium, 2+ in aqueous form, is going to yield SrCO3 in solid form. So this equation at the bottom, that is considered our net ionic equation because these are the only species directly involved in the chemical reaction forming that solid coming out of that solution. Alright, so have you accomplished the objectives of this unit? If not, you need to replay this video and rewatch the first couple of examples. You should also be able to answer any questions whenever we go over this lecture in class. Thanks.